transformer is a device that transfers electrical energy from one circuit to another without a direct electrical connection. It consists of two or more coils, known as windings, that are inductively coupled to each other. The primary winding receives electrical energy from an input source, while the secondary winding delivers electrical energy to a load. Transformers can change voltage and current levels between the circuits. An isolation transformer is a special type of transformer with an 11 voltage ratio, meaning the output voltage is the same as the input voltage. It provides electrical isolation between the input and output circuits, preventing direct current flow between the circuits, eliminating ground loops and reducing electrical noise. The primary function is to protect sensitive equipment from electrical problems, such as power surges, ground faults, and electromagnetic interference, often abbreviated as EMI, or radio frequency interference, often abbreviated as RFI. The key differences between a standard transformer and an isolation transformer primarily revolve around voltage ratio, isolation capabilities, and intended purpose. Firstly, considering the voltage ratio, transformers can have varying voltage ratios. This means that they can step up or step down the voltage from the primary winding to the secondary winding. For example, a transformer might take 120 volts and step it up to 240 volts, or vice versa. This is achieved by having a different number of turns in the primary and secondary windings. The ratio of turns determines the voltage transformation ratio. In contrast, an isolation transformer has an 11 voltage ratio. This means that the output voltage is the same as the input voltage. Its primary function is not to change the voltage level, but to provide electrical isolation. Secondly, in terms of isolation, an isolation transformer provides electrical isolation between the input and output circuits. This isolation is achieved through the physical separation of the primary and secondary windings, typically with an insulating barrier between them. This prevents direct current flow and reduces the transmission of electrical noise, ground loops, and transient voltages. A regular transformer, while still providing some degree of isolation through inductive coupling, does not offer the same level of electrical isolation as an isolation transformer. Thirdly, when it comes to purpose, a transformer is generally used to change voltage and current levels to match the requirements of different circuits or devices. They are widely used in power distribution systems to step down high voltage from transmission lines to low voltages suitable for residential or industrial use. They are also used in electronic devices to provide the correct voltage levels for various components. On the other hand, an isolation transformer is primarily used for isolation and protection of sensitive equipment. It is designed to protect equipment from electrical noise, ground loops, and power surges, ensuring stable and reliable operation. Regarding applications, regular transformers are widely used in power distribution networks, industrial applications, and electronic devices. For example, they are used in substations to step down high voltage electricity from transmission lines to lower voltages for distribution to homes and businesses. They are also used in appliances such as televisions, computers, and power adapters to provide the correct voltage levels for their internal circuits. Isolation transformers are essential for protecting sensitive equipment in environments such as medical facilities, computer labs, and telecommunications systems. In medical facilities, they are used to isolate sensitive medical equipment from the main power supply, protecting patients and staff from electrical shock hazard. In computer labs and data centers, they are used to protect computers and servers from power surges, noise, and ground loops, ensuring the integrity of data and preventing equipment damage. In telecommunications systems, they are used to isolate communication equipment from the power grid, reducing noise and interference and improving the reliability of communication signals. Isolation transformers isolate equipment from ground faults, reduce electromagnetic interference and radio frequency interference, and prevent damage from power surges, ensuring the longevity and reliability of sensitive electronic systems. In summary, a regular transformer is primarily used for changing voltage levels, while an isolation transformer is primarily used for providing electrical isolation and protecting sensitive equipment from electrical problems. Consider a scenario where a medical device is connected directly to the power grid. The power grid is susceptible to voltage fluctuations, surges, and noise, which can damage the sensitive electronic components of the medical device and potentially harm the patient. By using an isolation transformer, the medical device is electrically isolated from the power grid, protecting it from these electrical disturbances. The isolation transformer prevents direct current flow between the power grid and the medical device, eliminating ground loops and reducing electrical noise. It also blocks voltage surges and transients, preventing them from reaching the medical device and causing damage. Furthermore, isolation transformers are often used in audio recording studios to prevent ground loops, which can cause hum and noise in audio signals. By isolating the audio equipment from the power grid, the isolation transformer eliminates the ground loop and ensures a clean and noise-free audio signal. Another important application is in industrial control systems, where isolation transformers are used to protect programmable logic controllers, abbreviated as PLC, and other sensitive electronic equipment from electrical noise and surges generated by motors, drives, and other industrial equipment. The isolation transformer prevents these electrical disturbances from interfering with the operation of the control system, ensuring reliable and accurate control of industrial processes. In general, an isolation transformer is a valuable tool for protecting sensitive electronic equipment from electrical problems and ensuring its reliable and safe operation. The 11 voltage ratio is important because it ensures that the voltage supplied to the protected equipment is the same as the voltage from the power source. This is crucial for ensuring that the equipment operates within its specified voltage range and is not damaged by overvoltage or undervoltage conditions. The electrical isolation provided by the isolation transformer is also important for safety. It prevents direct contact between the power source and the protected equipment, reducing the risk of electrical shock. This is especially important in medical facilities where patients may be in direct contact with medical equipment. In addition to the 11 voltage ratio and electrical isolation transformers often include other features, such as surge protection and noise filtering. Surge protection protects the equipment from voltage spikes caused by lightning strikes or other electrical events. Noise filtering reduces the amount of electrical noise that is transmitted to the equipment, improving its performance and reliability. When selecting an isolation transformer, it is important to consider the voltage and current requirements of the protected equipment. The isolation transformer must be rated for the voltage and current levels that the equipment will draw. It is also important to consider the environment in which the isolation transformer will be used. If the environment is harsh or dusty, the isolation transformer should be enclosed in a suitable enclosure to protect it from damage. A key application for an isolation transformer is in environments where sensitive electronic equipment is used. These environments include medical facilities, where patient safety is paramount, computer labs, where data integrity is critical, and telecommunications systems, where reliable communication is essential. In these environments, isolation transformers provide a crucial layer of protection against electrical disturbances, ensuring the safe and reliable operation of sensitive electronic equipment. Consider a scenario where a hospital uses an isolation transformer to protect its life support equipment. If a power surge occurs, the isolation transformer will prevent the surge from reaching the life support equipment, ensuring that it continues to function properly and provide life-saving support to patients. Similarly, a data center might use an isolation transformer to protect its servers from power outages and other electrical disturbances. If a power outage occurs, the isolation transformer will provide a backup power supply to the servers, ensuring that they continue to operate and that data is not lost. In conclusion, while both regular transformers and isolation transformers serve important functions in electrical systems, they have distinct differences in terms of voltage ratio, isolation capabilities, and purpose. Understanding these differences is essential for selecting the right type of transformer for a particular application. Regular transformers are primarily used for changing voltage levels, while isolation transformers are primarily used for providing electrical isolation and protecting sensitive equipment from electrical problems. By using isolation transformers, you can ensure the safe and reliable operation of sensitive electronic equipment in a variety of environments.